what is the function we have? So this, let me differentiate. No problem, I'm writing directly. There's the equation what we have, where A and B are constants himself is telling. Okay, now what is this? F is equal to, we know, F equal to minus du by dx. So therefore this will become 2a x cube minus bx cube. What is the condition for equilibrium? At equilibrium, F should be 0. So 0 equal to 2a x naught. That equilibrium position, let me call x naught. So what is x naught is equal to? X naught is equal to 2a by b. So what is that x naught? X naught is the position at which it will be equilibrium. I suggest you plot either, okay, the particle for small angular displacement. It will for small angular for small linear displacement, it will be SHM. So I suggest you like plot these curves or plot expression for force as a function of x. Then you can really analyze through that curve also. I'm just taking mathematically. Now you can ask questions, sir, like why you are bringing equilibrium? No, it's there about equilibrium only. I'll give small displacement. Go back all spring block systems. We had a discussion like this, no? If this is there here, then what we do? It is in equilibrium. Then I'll give small displacement. I'll slightly pull it and release, then we go to execute SHM, the same thing. At equilibrium, I'm going to displace the block. Then I'll check it. Then I'll calculate the restoring force. If the restoring force proportional to negative of displacement, then it will be SHM. So already have equation F is equal to. So now there's the equation here. So I'll put it now. So what we know is it will be like this. 2a x cube how to proceed now. Let me give small displacement here, x plus delta x whole cube b. Or I think we can simplify this one, no? This will be lengthy for calculation purpose. I'll do one thing. This will be any equation, can we write it? 2a minus bx by x cube. Okay, justified. Okay, to minimize calculation. So now what happened? Let me give small displacement about mean position. When I give small displacement, then x will change correspondingly. The force acting on the particle will also will get incremented by delta f. So this will become, so this 2a will not change. So 2a minus of b x plus delta x by x plus delta x whole cube. Equilibrium, no, this is. Okay, no. Okay, we'll solve it after this. Anything, can we simplify this one? How to solve further? So I'll proceed like this. 2a minus bx by x plus delta x whole cube minus of b delta x plus delta x whole cube. Will I agree this? This will be now what is this quantity? Delta x will be very much less than x because I'll give small angular small displacement. So therefore, this will become 2a minus bx by x cube minus b delta x by x cube. About what point? About equilibrium point is what I'm going to give displacement. This displacement. So here, if you write it as x naught, because now I'll change it. About equilibrium point, I gave displacement, so I'll write f naught, the force. So this will become x naught, x naught, x naught, x naught. Let me put that red color so that it will be easy for you. Okay, fine. So this is like, according to the equation, 2a minus b x naught by x naught cube. There should be good f naught. This will get eliminated. So we'll end up with the equation delta f is equal to minus b delta x by x naught cube. This delta f should be equal to ma. So look at that acceleration proportional to negative of displacement. So therefore time period will be 2 pi m x naught cube by b. What is x naught? We have here. This you have to substitute here. And I'll write final equation. 2 pi m by b. X naught is what? 2a by b whole cube. Anybody answer? 8m a cube by b to power of 4. Okay, this will be really little bit difficult because at equilibrium, I'm going to give some displacement. Then force will slightly get incremented. The not I shown afterwards so that you'll come to know. Actually, at equilibrium, so what is delta? What is delta x? What is delta x? What we have to define? Delta x is small displacement given to block at equilibrium position. Unless you don't try this, it's of no use. Finally, I'll bring it here because we have simplified. No? Okay, now the potential G, some things are, you see, look at the previous problem. It was quite straightforward, no? Like just differentiating. Some questions will happen are of this kind where you have to define, because here you can't, sir, why don't you do here only? Why not here? So it is not an SHM. So why force is not proportional negative of displacement, but here you did like that. That you said like a very small, say x is very small. That x you have to make it very small. So you're going to displace the body, then what happened? You're going to check it. Okay, I think I think these are some potential if they're given. So many different types of numericals are there. This lengthy spring block system may not be useful for mains exam. Keep in mind, kinematics of SHM will be much useful. And this superposition, potential if they give fx graph, if they give some equations f. So these are the types of questions what you can prefer for mains. For advanced, today what I discussed some lengthy spring block system, no, they're applicable. So do revision based on the type of exam you're writing. Okay, I think we'll stop it here. That x naught I had to show separately about mean position. So what is this f naught? Force acting on particle at mean position. I'll write it. Somebody is asking, sir, what is f naught? Force acting on particle.